So everyone, welcome here to my presentation about the revolution of IoT botnets. My name is Neduchal, and I'm going to talk about the past, the present, and the future in the IoT industry that is related to security. I'm a high school student, and I currently work for Avast as a junior malware analysis. I study IoT malware from day-to-day basis, so I've seen a lot of it, a lot of the malware I'm going to talk about today. So first question, does anyone know what's on the image? Put your hands up if you're aware of what it is. Anyone? Right. Okay. Yeah, we can see a dog, but right next to it is a very special thing. Exactly. It is a dog feeder that is connected to the internet. That was exactly my question when I saw it. I have no idea why it's connected to the internet. I mean, sure, you can feed your dog remotely, but why would you leave your dog in your home in the first place? Well, researchers have found multiple vulnerabilities in the thing. Yes and no. It is slightly related to the dog, to the machine, and it can be compromised remotely. What could that mean? Well, people can feed your dog remotely without you knowing. If you want to know more about this Internet of Things phenomena, you could check out the Twitter Internet of Shit. They share perfect examples of IoT devices that are pointless. Where, without further ado, we can move on to the old botnets. Old is quoted because we are talking 6 years back, which is nothing in the malware industry, but IoT was in its early age back then. And if I would go through every single botnet that was in that created back in the days, I would be here for a week talking straight. So what I decided to do is to sum up the common traits that the botnet had back before Mirai. One of the traits is telnet scanning. They were trying default passwords on open telnet ports on IoT devices in general, because why the hell not? You know, refrigerator has to have a telnet port open. Well, the next thing they did is they didn't obfuscate at all the code. They were written in a very dumb way, in my opinion. They didn't even try to hide, because they knew that there is no such a thing as antivirus on IoT devices. What they did with the compromised devices is they launched DDoS attacks, and they didn't even think about any other usage for the devices. Well, and then we have Mirai, which is basically the same thing, but hey, it's famous. What it did, what is it famous for, is some major DDoS attacks. But how it worked was very similar to the malware strains we had before. It scanned telnet with default, root and admin passwords, and it actually got into over 200,000 devices at one point, and it launched DDoS attacks on several websites, and they were record-breaking. It launched the DDoS attacks over 1 terabit per second, which shut down the provider OVH. And then it actually shut down the DNS provider that took down Spotify, Twitter, Reddit for a while. And that's how even ordinary people came to know it. Well, and then the creator decided, hey, I have enough money. I've sold the botnet to several people. What I'm going to do, I'm going to retire. So he released the source code. So Mirai went open source in 2016, and it's actually on GitHub to this day. So people are like, okay, we have the source code. What can we do with it? It takes a while to code a proper botnet. So They created Mirai variants, which is basically Mirai with a new name, because they added only slight modifications to the code. For example, what I have on the slide, those are 3 or 4, if you take pure Masuta as another botnet, created by one person. What he did was he cross-compiled it for more architectures than Mirai, and he added vulnerabilities instead of telnet scanning. Then we have Reaper, which you might heard of because he actually used some advanced techniques than Mirai for loading the malware on the device. He used a thing called loader, which how it works is there is an already infected device that is scanning the internet for vulnerable devices. So it finds a vulnerable device, it responds on a certain port, there is a possibility that it's vulnerable. So the infected device reports it back to a reporting server. Then after that, it tells the loader to scan the actual vulnerable device for vulnerabilities. It was loaded with them. The loader had several vulnerabilities, and after it infected the vulnerable device, infected remote code execution. So it executed a malicious command that downloaded the very same bot back onto the vulnerable device. It actually executed things like Lua interpreter, so the bot master could actually execute Lua commands or Lua scripts on the target device. Well, then people thought of, hey, everyone's doing DDoS attacks. Can we use the botnet for something different than plain DDoS? So guys that made OMG thought, hey, we have other projects that we work for or we work on. Let's make it a proxy chain. So they took the whole botnet and started using it as a proxy chain for other means. Well, to this point, if I'm not counting the botnets that I'm going to showcase later on, to this point, none of these botnets were persistent. That means if you reboot the device, they're gone. They didn't even care to put persistence in the bot. But Vic family did it. He added some additional exploits. Whenever an exploit comes out, he adds it to the bot, and they're persistent, so that's quite an upgrade. Well, does anyone here have any idea what APT means? We're at the Linux conference. Come on, guys. APT get anyone? Okay, no, it's advanced persistent threat, I'm sorry. What it is, it's a malware that targets a specific device or anything. It's highly targeted, and it's, the word advanced is in its name, so it is highly advanced. And that is, for example, VPN filter, which is a botnet that was discovered earlier this year by Talos Intelligence. They did a great blog post on it. And it is multi-stage botnet, so that means that it comes in stages. It first executes stage 1, which ensures persistence. So that means if you're on stage 3, stage 2, and you reboot the device, it goes back to stage 1. The only thing that stage 1 did is downloaded the stage 2, which acted as a module loader. So that means it connected back to the CNC and checked, hey, do you have anything for me? I can download some additional modules. So stage 3 modules, the first one that were released were the Tor module, the destruction module, and the Essler module. So the Tor module is quite self-explanatory. It could afterwards communicate with the CNC over Tor, and the destroy module just break the device straight away. What's interesting is the Essler module, which actually SSL stripped the communication on the local network and was sniffing passwords. So if we compare this botnet to the dumb Mirai that only scanned for passwords and then attacked the website, and that's all it did, we are getting closer to desktop applications of malware here. And the more stands for that recently it was actually updated again, and it added more functionality for SSH connections, local network scanning, so it could actually spread on the local network as well. Well, and then we have something very unique, in my opinion. I really like this botnet. I know it's not a fair thing to say to like something this malicious, but I actually quite like this design because it doesn't have a command and control server that commands the whole botnet. The whole botnet is a peer-to-peer network, so there are nodes that communicate between each other, and the command and control is actually one of the peers that only distributes the command to the whole network. So there is no way how to shut down this network in an efficient way, because we actually have no idea where the command and control infrastructure is. In the botnets I talked before, the IP was usually hard-coded, or there was a domain that it resolved. So, server can be taken down. We are talking about a whole network full of vulnerable devices, and we have no idea which one to take down to stop the botnet. And even if we did, he will just connect another one and distribute the payload with it. And what this botnet does is it runs not proprietary, it runs a protocol, a custom protocol that can distribute binaries between the peers. Well, the configuration file has to be signed, so there's no way in us injecting some binaries that can actually cure this. Yeah, it is very unique opposed to the other botnets, which, as I mentioned, in my opinion, they are very dumb compared to this. Well, what the impact was of everything I just mentioned? Well, vendors that are to blame for this, they actually started to care. They are releasing patches, newer devices like Alexa and everything. They are not vulnerable by default. They're getting automatic updates. The passwords are strong. But frankly, there are still manufacturers that don't care, and malware authors that are starting to care, because they see the possibility of building huge botnets out of nowhere. They hard-code an IP. They create a botnet of 20,000 nodes. It's gone in 3 days, but they will use it in the time period they have. And that's what we see quite lately, which is interesting. Well, and the other aspect of the impact that this had is arresting of this guy that the name I cannot pronounce. Don't blame me for it. It's his fault. He created Mirai, and he released the source code. But he didn't actually get jailed because he was helping the FBI with other investigations, so he just got community service. Well, and the other guy is a creator of Satori, Masuta, and all the network families related to Satori. He's awaiting his sentence right now. Well, and how can we prevent our home network from getting infected with a botnet? We don't want our refrigerator DDoSing Google. Well, there are complex and simple solutions to this. If you are a normal guy like me, you're probably not running an intrusion detection system on your home network. If you're a company, well, do it, because you don't want your IP or your company DDoSing anyone. Well, the slightly advanced prevention technique is to check your firewall rules, because the botnets are looking for open ports on the internet. So if you don't allow open ports from your home network, well, then you're not getting one. And the simplest solution is to reboot. Reboot everything once in a while, because it actually deletes the botnet from the vulnerable device, because it's not persistent, as I said, in most cases. Well, everything's great, but hey, how do they do it? So for the purpose of this presentation, I've decided to actually try to build a botnet and see just the binary, just the code. Okay, I didn't spread it, don't worry. Just to see how easy or hard is it to build a thing like this. Well, I've come up with 3 questions I have to ask myself. What language to choose, what communication protocol to choose, and spreading method to use. Well, language. Everyone's coding their botnets in C because it's a low-level language. It can be compiled for everything. It is just great. But for me, I'm a lazy person. I'm a programmer. I wanted to program in something that is multi-platform and easy to write. So I chose Bash. Why not? It runs on the devices. They have an interpreter. Why not use Bash? Communication protocol to choose. Well, Mirai and its variants use a raw protocol that sends bits and bytes to the command and control server that responds in a way so they know what to do. And I was thinking, why would I make it complicated like this for me? Let's just use HTTP. Why not? Everyone's doing it right now. And what spreading method to use? So telnet scanning, everyone's done it. It's no longer viable for a proper botnet. So vulnerabilities, of course. Once a week, there is a new vulnerability for a router, refrigerator, smart dog food dispenser, whatever. You could hard code it to the bot and it will just work. And you will get a lot of devices. But there is another thing that can be used, which is, I just like to mention this, that it is actually possible to do. Inject JavaScript into websites that scan the local network for vulnerable devices. So it can infect devices behind the net, which is something that little to none botnets did. And that's why they, quote unquote, only got 200,000 nodes. Why not millions or billions? Well, I went with vulnerabilities because who wants to write JavaScript, right? Showdown.io. Michal Spacek here did a great presentation yesterday about Showdown. So I'm just going to recap real quick. It is a search engine for IoT. That's it. Well, it looks like this. This is actually a query you can see in the search bar for vulnerable MikroTik devices. And by vulnerable, I mean already exploited. They are being used to mine cryptocurrencies. And in the top left corner, you can actually see how many devices are already infected and running CoinHive. It is a huge number. Here are the statistics for the most infected countries. And data like this can be used in two ways. It can do great statistics for a presentation, or I can feed the IPs to my botnet and actually spread it like this. So that's just food for thought. And also, I'd like to showcase how easy it is to exploit IoT. So right here, I have a MikroTik router I purchased 2 days ago from Alza. It is still shrink wrapped. It's brand new. It's like I got it from the shop. So what I'm going to do, I'm going to use the very same thing and method they used to hijack those MikroTik routers that mined cryptocurrencies. And I'll try to get the default login and password, not the default one, the default one's empty, from the router. So, good, we're connected. So here I have Winbox. Is everyone here familiar with Winbox? I want to see the hands. Okay, so not many people. Well, Winbox is a software to connect and maintain the MikroTik routers. So I'm just going to connect to mine real quick. Okay. And I'm going to set up a password that we can then see being exploited. Users, admin. Wait, no, password. Was it? Oh, yeah. God. OK. So I'm going to enter a super secret password. Oh, no, the presentation's on. OK. OK, it's definitely not 4 characters. I'm going to close this, and I'm going to go to my trusted terminal, where I already had the demo. God damn. And I'm actually here. I downloaded a POC from GitHub that is publicly available that can exploit it for me. Why should I write the exploits myself when I can just go on GitHub, download something, and it works? So there we go. The default IP. And what do you know? It's right there, my super secret password. And what could I do from now on? Well, me, as a highly malicious person that has the intent to rule over all IoT devices, I could go on and log into the router and use it for my nefarious purposes, such as SSL stripping or proxying the connection or mining Bitcoin, whatnot. Well, it was that easy. I just went on GitHub, downloaded something, and it works with a thing I bought straight away. Well, and how the exploit works, just a TLDR. Well, the program that I ran said hello to the router through the Winbox protocol. And the router responded with a message that contained a session ID, which then I used to request the database. And what do you know? The router responded, sure, there you go. So I decided to write the botnet in Bash. And I've actually did it under 60 minutes. It is 60 lines of code. It works on the local network, of course. I didn't release it. Shh. OK. And I'm going to show how it works real quick. It's written in pseudocode because several people told me not to showcase the full source code of it here. I have no idea why, though. Well, there is one huge while loop that generates an IP address, then sends the exploit blindly on the IP address. It depends on the port specified in the exploit. Then it downloads a command from a CNC server and just runs it. Simple as it may seem, it is just like that, and it works. So if I want to execute, remove everything from root, I just write it on my CNC/command. The bot will download it, set the permissions, and run it. And there we go. We just bricked everything that's infected. Hooray. Well, I even written a persistence function, so I'm already better than Mirai, right? Because it wasn't persistent. This is the actual bash code that I've written. It just uses things that are available on every device that's running Linux. And then there are leaked sources of botnets that people can use. They are available on the internet, again, on GitHub, and basically everywhere. You just Google for them, they're right there. And for me, as a malware analysis, that's very good if someone uses it, because it's a lot of fun to reverse engineer, right? If someone writes a new type of botnet from an already leaked source, that means that it's good, right? So I usually look at it like this. Hey, this is really good, although it's not. But this is actually better for me than the skid way, the script kiddie way. People can actually go online and download or buy the bots ready for them for little as $10. You can just go online and buy a botnet for $10 and it works. Well, it has a hard-coded IP, so it works for 2 days, but hey, you spent $10 on it. And there are things called stressors, which I'm going to showcase real quick, how easy to find them. Well, stressors are websites where you can order DDoS. So I'm just going to go on Google, type stressor, hit enter, and I'm not connected to the internet. Great. Turn on the Wi-Fi real quick. Stressor, what do we have here? Oh, there we go, 3 years running, woohoo. So it's reliable, right? So I can just log in here and launch a DDoS attack from a website that I have no idea what it actually does, but it works. It's a legitimate DDoS attack. It's indexed by Google, and everyone can find it. That's scary, at least in my opinion. So I don't think that's cool. Well, in the conclusion, we're in the age of APT botnets, and what the trends currently are persistence and multi-stage malware that is highly advanced. If we look at it from the perspective from the past, well, and making botnet is fairly easy, right? It's 60 lines of bash code. Who couldn't done that? Well, vendors should do definitely something about it, because it's their fault and their responsibility for secure IoT devices. It's not the responsibility of people to fix something that someone made bad on purpose. And lastly, what I want to finish this presentation with is rebooted router is a happy router because it doesn't run malware in it. So if anyone has any questions, I'm open for them. Jo, počkej. Musíš podržet to tlačítko na to.
Hello? Je mě slyšet? Jo. Well, what is the vulnerability you used in your botnet so I can patch my router in advance?
Right. Yeah. What I've written, the hard-coded in my botnet was the GPON vulnerability that targeted Huawei home gateways. Okay. So if you have one of those, you should patch it.
How about state-sponsored botnets? How is there like?
All right. Yeah. The VPN filter is thought as like a state-sponsored botnet because, as I said, it's highly advanced, and the spreading methods it used were quite different from the average botnet. It actually utilized a type of obfuscation during the spreading method. So it used photobucket, I think it was photobucket, and it extracted the CNC address from a image that was hosted on photobucket. So people think it is made by a state-sponsored actor, but no one can really be sure if it was a state actor or not. You know, there's no one that can confirm if it's true or not. Yeah. I'd say that to 2016, only a minority of botnets actually used exploits. Most of them were brute forcing credentials because usually people don't change the default ones. And the companies don't enforce anything like that, or they straight up don't even have an option to change the password. So Telnet just used the default one, And yeah, I mean, Mirai had over, I think it was 150 hard-coded passwords that it tried on every single host it scanned for telnet. Well, it depends on what the activity are we talking about. If it's a DDoS attack, or right. I mean, that type of attack can be prevented by a standard antivirus because it looks for those type of attacks, but it cannot say where it came from. If it's the website's fault, or is the router injecting the JavaScript. So there's no good way how to detect something that resides on your router if there is not a software that's looking for it on the router.
It's a kind of, maybe I would say, to put some my router and
It would have to be after the router in the upstream. Exactly. That's where you would detect it. I mean, I would not recommend setting up a full intrusion detection system. What I would recommend is disabling UPnP if you don't use any devices that use it, because it is abused almost in every other exploit. There is a UPnP that the parser didn't sanitize correctly. So I would start with that and maybe look into firewall rules, that you don't actually forward telnet from your refrigerator on the internet. So that's a good start, in my opinion.
Okay, so if I would want to set up an IDS, I would recommend. I got the answer.
Oh, yeah. It's been patched already, but we're talking about the firmware before the patch. So all those that I showcased in Showdown, they were actually already infected using the vulnerability. So yeah, I mean, there is more of them vulnerable, but Showdown cannot search for the firmware version, if I'm aware. So yeah, I mean, 250,000 devices that already been exploited. I think that's a pretty good number for a botnet, but it's not a botnet, it's mining cryptocurrencies. Okay, so if that's all, I thank you for your attention and hopefully see you next time.